Hi, everyone. Thanks for attending our short talk on FAIRifying your multi-omics data. I'm Qian, a solutions consultant at Genestack. Before we go into the main content of today's talk, I'll give a brief introduction to our company, Genestack. We specialize in multi-omics data management, integration, and research and search. Our goal is to help our customers to leverage high-throughput multi-omics data and fast-track drug discovery, precision medicine, and bioinformatics research. We headquartered in Cambridge, UK. We closely working with multiple clients across different sectors. For example, Roche, AstraZeneca, Unilever, Corteva, and more. Our flagship product, Omics Data Manager, is the culmination of our collaboration with industry leaders. It provides the top integrative multiple omics data management platform on the market. We also provide full professional services and consultancy along our journey with our client. So what is ODM? ODM fills the gap between data lake and visualization and analytics application development. On one end, data lake tends to lack data standardization, data lineage, insufficient metadata management. While on the other end, visualization application development tends to suffer from incomplete and low quality data. ODM addresses this gap by providing single point of truths to structure and standardize different data types, an integration layer to capture their relationships, as well as various tools to curate and validate metadata. So today we'll focus on the three main challenges that lots of researchers faces on a day-to-day basis. First, how to track which samples have which omics data, how to capture and harmonize data from different sources, and perform cross-study and cross-omics queries. For the very first challenge, how to track multiple omics data is the most often asked and important question researchers always have. For example, where's my data? How can I find omics data for a particular sample? Why this is so difficult to find and access data? Very often, different omics data may sit in different systems. For example, you can have one proteomic data, and you can have transcriptome and genomic data elsewhere. And also, the data itself is not properly linked with the metadata attached to it. For example, you can have a LIMS ELN system for recording all the experimental data while your actual data stays elsewhere in another system. Also, some systems does not have data model that support different types of data, which can cause issues in locating and searching and linking them. ODM helps to integrate multi-omics data from different sources in one place, which also enables user to search and explore different studies and their relationships. Later, I'll give a quick demo on this feature of ODM. The second challenge is always, how can I harmonize the metadata from different sources? Many times you may have experience that different groups, CROs, public sources use different data standard. For example, different annotation files for genomic data or different ways to record experimental metadata. Even if this is all sorted, when you receive the file, you may realize there are lack of ontologies and control vocabularies. For example, a patient sample can be labeled as lung cancer or lung adenocarcinoma, which actually refer to the same patient samples, but from different CROs or different groups. Even after overcome all those two challenges, you may end up spending a lot of time to clean up and correct your metadata. Our product, ODM, will enable you to enrich and clean metadata. You can create templates that describe for each data type what attributes are required, what ontologies and control vocabularies to use. In addition, ODM power you with the tools to validate and curate your data by alerting users for invalid metadata, perform bulk replacement and automated metadata mapping. I'll pause here for a little while to give you a quick demo about the features I just mentioned in ODM. Once you log onto ODM system, you're directed to this dashboard. For the demonstration, we'll just go directly to the study browser. As you can see here, I can browse and view all the studies I have authorized with access. You can also filter the data using the left-hand filtering sets. For example, what type of data you want to filter: expression, variant, flow cytometry, and also sources and other additional filters. We also provide a Google-style text search on the top of the bar of the study browser. For example, I'm interested in TCGA dataset. I'll type that in, click enter. They will return a list of studies which contains TCGA. For example, we'll just go into TCGA lung adenocarcinoma study. As you can see here, there are multiple tabs with metadata included. For the study, you will be assigned a unique accession ID on the system. And also you can input descriptions to describe what's included in your study. And sample, you can view all the sample information here, and you will realize the fourth column is a unique accession identifier for each sample. As I mentioned, there is a predefined ontologies and control vocabularies that we use in the template. So you can see those light pink warnings. If you click on the invalid metadata, they will tell you there are 11 empty cells. And also there are other cells with terms that not comply with the predefined ontologies and control vocabularies. If you click there, you'll be able to do bulk replacements using terminologies defined previously. Due to the time limit, I'll stop here and go back to our presentation. We've been talking about the major three challenges researchers has been facing. And the third challenge is to perform cross-study, cross-omic queries. This is mainly related to the previous two challenges I've been mentioned. For example, data metadata are not integrated properly. And also often, some systems are not capable to provide customized options for existing visualization and analytics application development, or really hard to scale up against single cell or population-based data. ODM's unique technologies, single point of truth, integration layer, and integrity API queries will solve this very easily. We can easily query any data in ODM through our RESTful APIs using Swagger GUI or any scripting language, such as Python and R. Here is an example of an API-based R-Shiny app, which can be used to query bulk and single-cell RNA sequencing data, which I'll give you a little demo now. Once you open this R-Shiny app, you can select the type of study you're interested, either bulk or single-cell study, and also select an area of interest. Here, I'm interested in immunology. A list of studies which are categorized as immunology area will be listed here. I'll tick the first one. I'm interested in a T-cell marker called CD3E. In the main panel, you have plot with proteomics and RNA-seq data for this gene across all the cell types in the dataset. You can also view information on gene, study, sample, expression, as well as the API calls used to generate and retrieve the data from ODM. You can further narrow the filtering system to lymph node cells. As you can see here, the cell types has been reduced to lymph node cells only. And also you can add more cells, more genes of interest, and do further filtering. Say, we're only interested in RNA-seq data, and you just filter the expression filter. And here you can see only RNA-seq data are shown for both. Also, you can tick all the studies under this area of interest. You can apply the same to single-cell RNA-seq data. We'll quickly show you. This time, I'm interested in oncology. I'll choose the first dataset. And T-SNE plot is one of the most interesting clustering techniques people are interested to use for single-cell RNA-seq. As you can see here, that's the T-SNE plot returned from our query. I'll stop here. If you're interested in more detailed demos, please book us for one-to-one session. I'll close today's talk with this presentation. We are very keen on finding new industry collaborations. We understand how hard and challenging it is to build a data landscape. Therefore, we encourage to build industry standard solution together through knowledge and cost sharing, where we can strategically avoid common pitfalls and accelerate development. Our currently main focus are single-cell and clinical omics data integration, especially for ongoing in-flight trials. It is an exciting time for us to work with multiple clients and also an opportunity for you to join us for this collaboration. I would like to also raise attention to other talks we're doing in the following 2 days. Kevin, our head of data science consulting, will give a virtual talk on how to build a more integrated and scalable omics data landscape on Wednesday. And there are 2 other short talks on how to generate insight from your multi-omics data and integrate omics data and clinical data. You're very welcome to join us for any one-to-one sessions, for a detailed demo of ODM, or business discussion. Thank you. You can contact us through this email, inform@genestack.com.